Hello math learners, so for today's video we're going to proceed in our general chemistry lesson, which is empirical and molecular formula. So for more information about this lesson, watch this video till the end. So let us start. So syempre may tayong prerequisite sa ating lesson, which is yung percent composition na diniscuss natin ng mga past videos natin. Ngayon, ano ba pinagkaiba or what is the difference between the empirical and molecular formula? In terms of empirical formula, it is the simplest whole number ratio of elements. Yun, pagka sinabi naman nating molecular formula, it is the actual whole number ratio or the multiple of empirical. So ngayon, magkaiba yung dalawa. So, yan na natin yung mga steps. How to evaluate them. So, una, so we have empirical formula. So, step 1, you have to transform all the percentage into grams and convert them into moles. Next is to divide both moles that you got. The lowest mole. Ganun lang. 2 steps lang sa pag-evaluate ng empirical formula. Next, we have molecular formula. Excuse me. So, you have to do the same procedure in empirical formula, but with the twist. To calculate the molecular formula, divide the given molecular weight to its computed empirical formula's molecular weight. And that, you are going to use the molecular formula, in-F ko na lang, to multiply your empirical formula. Kasi merong iba na unfamiliar element from the empirical formula na kailangan din natin evaluate. So, paano yun? Let's have some problem to solve and to apply the steps to understand what I am talking about on those steps. Okay? Number 1, so what will be the empirical formula of 47.76% copper and 52.24% of chlorine? Alam naman natin pag pinag-add yan, it will sum up to 100%. So by applying the steps, so number 1 is to transform percent of each element in grams and convert them into moles. So for copper, so this percentage, like what we have said, transform from percent to grams. So we made it into grams. Using the conversion factor, in 1 mole of copper is equivalent to 64 grams. So if you're going to use or take a look on your periodic table, you'll be able to know its, the conversion factor. In 1 mole, this is the mole, and this is 64 grams. 64 grams per mole. And if you're going to use your calculator before that, so you have to cancel the grams here. And what you're going to do is to simplify, and you will get 0.75 mole of copper. For chlorine, we have 52.24. Instead of percentage, you're going to translate it or transform to grams, as easy as that, of chlorine. If you're going to multiply, what is the molar mass of chlorine? In 1 mole of chlorine is we have 35 grams. This is the molar mass. Then if you're going to cancel grams, syempre, and what you will have is mole and the chlorine. For the unit is we have 1.49 moles of chlorine. Okay, what is the next step? You have to divide the both moles you got to the lowest mole you got. So what is the lowest between the two? We have 0.75. This will be your lowest. Okay? What's next? This is what you got for your empirical formula. The mole. Okay? This is the lowest, the 0.75, of course. So, for the copper, 0.75 mole divided by, what is the lowest? Of course, 0.75. Then, makakancel ang mole. Then, you will get 1. Okay. Next, we have chlorine. Equals, so we have 1.49 moles of chlorine and divided by 0.75. Cancel ulit ng mole. Ang lalabas is 1.9866666. But most likely, we're going to estimate it into the nearest tenths or one decimal place when it comes to empirical and molecular formula. And you will get 2. Therefore, the empirical formula is CuCl2, or we can read it as copper chloride. Metal, non-metal. Yan. 2 because chlorine consists of 2 moles and copper 1 mole, copper chloride. Okay, let's hope everyone gets what we did in empirical formula. Next problem. The compound ethylene glycol is often used as an antifreeze. It contains 38.7% of carbon. We have 9.75% of hydrogen and 51.55% of oxygen. The molecular weight of ethylene glycol is 62.07 grams. What will be the molecular formula of ethylene glycol? To apply the steps of molecular formula is what we are looking for. So we have to do the same procedure in empirical formula. For carbon, we have 38.7 grams of carbon to be multiplied in 1 mole of carbon is equals to 12 grams. So how come? That is the molecular mass or molar mass. Okay. To be cancel ang grams. And we have to simplify. So we have 3.23 mole of carbon. For hydrogens, we have 9.75 grams of hydrogen percent to grams. Okay? Times 1 mole of hydrogen is also we have 1 gram. Actually, that is also 1.008, but we chose to round off all the molecular masses of the elements into whole number. Okay. So, we cancel ang grams, then we will have 9.75 moles of hydrogen. Even you can use the as-is value of those molar masses that have you seen in periodic table, it will still the same. Yun at yun pa rin ang lalabas. Okay? Medyo, gano'n lang din naman. Kasi hanapin nyo yung pinaka-lowest, tapos di-divide nyo rin. Gano'n lang din. Okay? For oxygen, we have 51.55 grams of oxygen to be multiplied in 1 mole all over 16 grams because this is your molecular mass. Cancel ang grams, then ang lalabas is 3.22 mole of oxygen. Which of the three are the lowest? This is the lowest. Now, after that, since we're doing the same for molecular to empirical formula, we have to divide all of them to the lowest one. 3.22 since this is the lowest. Same with this. Same with this. Inalis lang natin yung mga dapat alisin. Ayan. Since alam naman na natin ang lowest, so now dinivide na natin siya kung saan yung lowest. Of course, ito 1 ang lalabas. Ito 1. Kahit itry sa calc, actually that is decimal yan eh. Pero 1 na lang. Okay? Ito 3. Actually, meron yung 2 point blah 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 eh. Or 3 na 3.00 blah blah blah. Ganon. Ito naman, 1. Therefore, the empirical formula is CH3O. Di natin siya mapapangalanan kaya gagamit tayo ng molecular formula. Di naman siya ganun ka nag-exist tong element na to. So now we're going to apply step 2. So we have CH3O. Ito yung lumabas na ating empirical formula. Okay? So ngayon, for molecular formula, molecular weight is all over the empirical formula weight. Okay. To get the empirical formula weight, since alam naman natin this is 12, yung hydrogen nyo, this is 1, yung oxygen nyo, this is 16. So 16 plus 3 times 1, 19, plus 12, 31. Okay? Ganun lang. Diba madali lang, para naglalaro lang tayo dito. Okay, so ngayon, ito yung inyong molecular weight. Para, if you're wondering. Ngayon, apply natin, substitute lang. We have 62.07 grams all over 31 grams. So, if you're going to cancel the grams, kakancel yung grams. Pero di ko na yata kinancel siya. We have 2. Okay? So, 2 ang inyong molecular formula. Your multiple. Na ngayon, ay gagawin yung subscript. Okay? Sabi dito, use MF to multiple your empirical formula. So, ganun ang nangyari. So, ito i-distribute nyo yan. So, 1 times 2, 3 times 2, and 1 times 2. So, magiging C2H6O2. So, ito, nag-exist tong molecular formula na to, which is
ethylene glycol.
yan. So, ito na yung inyong molecular formula for the ethylene glycol. Okay, for the motivity, so, the compound dioxane contains only carbon, hydrogen, and oxygen. When 0.956 grams dioxane is burned, 1.91 grams of carbon dioxide and 0.782 grams water are formed. In another experiment, it was determined that 6.04 times 10 raised to negative 3 or 6.04 millimole dioxane weighs 0.532 grams. What is the molecular formula of dioxane? So, this is the activity you can try on your own. And we will magre-reveal tayo ng mga answer ng mga activities na inaano ko sa TikTok. Coming soon. Ang revelation ng mga answer natin sa mga nire-reveal ko dito sa aking vlog sa YouTube. At i-reveal natin siya sa TikTok. Yan. So, ngayon, well done. So, today, this is gonna be the end of our video for today. And hopefully, you have learned something today. And thanks for watching and see you in my next video.